Welcome to The Explainer. Today, we're going on a hunt for a ghost. I'm talking about an invisible substance that makes up a whopping 85% of all the matter in the universe, and yet we have absolutely no idea what it is. Let's dive into the cosmic detective story of dark matter.
All right, let's just jump right into the big problem, the one that keeps astronomers staring at their ceilings at night. Here it is. The galaxy we're in right now, the Milky Way, it's spinning so incredibly fast that, well, it should have ripped itself to shreds by now. Seriously. Based on all the stars and gas we can actually see, there just isn't enough gravity to hold it all together. It should have disintegrated eons ago. So, what's the invisible glue?
So, this whole mystery really gets going back in the 1970s. You've got this brilliant astronomer, Vera Rubin, and she's looking at how other galaxies spin, and she finds something weird. Something that just doesn't add up. In fact, it looked like it was breaking the fundamental laws of physics.
Okay, think about our own solar system for a second. You've got Mercury whipping around the sun super fast, right? But way out at the edge, Neptune is just kind of crawling along. And that makes total sense. Gravity gets weaker with distance. So everybody figured galaxies would work the exact same way, but they don't. Not even close. The stars way out on the fringes of galaxies, they're moving just as fast as the ones in the middle. It's just impossible. It's like there's some giant invisible mass out there, grabbing them and keeping them in orbit.
Okay, so if we can't see enough stuff to explain all this gravity, how in the world can we be so sure there's invisible stuff making up the difference? Well, this is where the cosmic detective work gets really cool.
It all boils down to a really simple but powerful idea. Think about it. You can't see the wind, right? But you know it's there because you can see the leaves on the trees shaking. You see its effect, and that's exactly what scientists are doing. They're looking for the universe's version of rustling leaves.
And that right there is the key to this whole thing. We can't point a telescope at dark matter and take a picture, but what we can do is see its powerful gravitational fingerprint all over the cosmos. We see it pulling on stars, making them go way too fast. We see it literally bending the light from distant galaxies. It's everywhere.
All right, let's crack open the case file. I want to walk you through the 3 biggest clues that have convinced pretty much the entire scientific community that dark matter isn't just some wild idea, it's a real physical part of our universe.
Clue number 1.
This is the one that kicked everything off. It's those ridiculously fast-spinning galaxies we were just talking about. This is the original smoking gun.
Okay, so take a look at this graph. It lays out the problem perfectly. See those dashed lines way down at the bottom? That's how fast the stars should be going based on all the matter we can see. Now, look at the dots way up top. That's how fast they're actually going. That gigantic gap? That's the mystery. That's the missing gravity. And the best explanation we have is that the galaxy is sitting inside a huge invisible halo of dark matter.
Okay, clue number 2. This one comes from one of the craziest ideas in all of physics, thanks to Einstein. The idea is that really massive objects don't just have gravity, they actually warp and bend the fabric of space and time itself. And if you can bend space, you can bend light.
This is called gravitational lensing. Basically, a huge clump of matter, like a galaxy cluster, acts like a giant magnifying glass in space. So when astronomers look at one of these clusters, they can see the light from even more distant galaxies behind it getting stretched and distorted. And here's the kicker, they can use how much the light is bent to calculate the mass of the cluster. And guess what? Every time they do it, the answer is the same. There is way more mass there than what we can account for with visible stuff.
And this image is just mind-blowing. What you're looking at is the aftermath of 2 entire galaxy clusters smashing into each other. Now, the normal matter, that hot gas you see and think, it crashed and piled up in the middle. But the dark matter, which they've mapped out in blue, just passed right through, like a ghost. This is huge. It's the visible matter and the dark matter separating from each other. This is about as close to a direct photograph of dark matter as we've ever gotten.
All right, our third and final clue. And honestly, this one might be the most mind-boggling of them all. It comes from looking at the big picture, the actual recipe for the entire universe.
So, scientists can look at the leftover light from the Big Bang. It's called the cosmic microwave background, and from that, they can figure out what the universe is made of. And the results are, well, they're shocking. It turns out that everything you've ever seen or even heard of, every star, every planet, you, me, this screen, all of it is only 5% of the total stuff in the universe.
So what's the other 95%?
Well, most of it is an even bigger mystery called dark energy. We'll save that for another day. But if you just look at the matter, the actual stuff in the universe, a jaw-dropping 85% of it is this dark matter we've been talking about.
So you add it all up, the spinning galaxies, the bent light, the recipe of the universe, and the evidence is just overwhelming. Something is out there. Which of course leads to the billion-dollar question. What in the world is it?
And believe me, the hunt is on. There's a whole list of suspects. You've got physicists building detectors a mile underground, hoping to catch a glimpse of these things called WIMPs, weakly interacting massive particles. Others are looking for these super light particles called axions. There's even an idea that dark matter could be a swarm of tiny black holes that were created right at the beginning of time. It's a huge race to find out who's right.
Now, I should say there is a fringe idea, a fascinating alternative. A small group of scientists thinks we've got it all wrong. Their theory, called MOND, says maybe there isn't any missing matter at all. Maybe our theory of gravity is what's missing something. What if over huge galactic distances, gravity just behaves differently than we expect? So it's this big debate. Are we missing some stuff, or are we missing some physics?
Okay, so why should you care about any of this? Why does some invisible stuff out in space matter to us here on Earth? Well, as it turns out, dark matter isn't just some weird, distant curiosity. It's actually the reason we're here at all. When scientists run computer simulations of how the universe began, they find something incredible. If you take dark matter out of the equation, you don't get galaxies. You just get a thin, boring soup of hydrogen gas forever. See, in the early universe, dark matter formed this kind of invisible cosmic web, this gravitational scaffolding. And all the normal matter, the stuff we're made of, was pulled into that scaffolding, where it could finally clump together and start forming stars and galaxies.
And that's really the big takeaway here. This isn't just an abstract physics problem. Dark matter is fundamental to our own origin story. Without it, there would be no cosmic web. Without the web, there'd be no Milky Way. No Milky Way, no sun. No sun, no us. Our entire existence is built on the foundation of this mysterious, invisible substance. So I'll leave you with this final thought. We've just realized that 85% of all the matter in the universe has been completely invisible to us this whole time, hiding in plain sight. It kind of makes you wonder, right? What else is out there? What other huge secrets is the universe just waiting for us to discover?